Come on. Okay, so it's 6:30. I'm going to start. I'll try to go a little bit slow when I get to things that, you know, are kind of critical for being a sketcher. But in general, feel free to ask some questions if you have questions. You can ask by the chat, and then, I mean, if we unmute everybody, it could be chaos. I don't know, but we'll see. And so anyway, so I'm going to start. And so for those of you who've never sketched before or sketched this just a little bit, so you want to be a sketcher, huh? So what I'm going to do is I'm going to go through a couple of things here, and this is generally what I do in my sketching workshops that I do in person. And I talk a little bit about why we map caves. I know that you all think, well, yeah, we know why we map caves. Well, you know, for a new sketcher, it might give some perspective to help them understand why we do things the way that we do. I'm going to give you a little tools of the trade, my favorite things to use as a sketcher. You know, if you're using the right equipment, you'll always do a better job. Although, if you really know what you're doing, you can sketch with crayons and you'll still be good. I'm going to go over use of a protractor, just because I find that for people who are beginner sketchers, they don't even realize they don't know how to use a protractor. And the protractor is like the backbone of your sketch. Now keep in mind that we're not doing, you know, in-cave digital sketching yet. And I think that's a great idea. And at some point, you know, I think we're all going to do it. But right now, you know, in order to be a good sketcher, no matter what tool you're using, you kind of need to understand the basics. So I will go over use of the protractor, some map symbols, sketching to scale, just an overview. I'm going to try to show plotting the survey line and plan and profile, cross sections, and I'll talk about survey standards. And somewhere in the middle here, maybe in the middle of class, we'll take a little bit of a break, because this is a lot of information to try to like cram down your throat at one time. So why do we map caves? Well, I map caves because I love to map caves. Well, basically, you know, the whole question about why we map caves has changed over the years, and survey standards have changed over the years. But really, what we really want to know initially is, where does the cave go? And what's the relationship between cave passages? And you don't know that unless you map the cave. Okay, let's see. So we want to know the spatial relationships of caves. That's important, especially if you're going to go connect a bunch of those together and come up with a big cave. You can't do that unless you map the cave. So in order to answer any of these questions, where does the cave go? What's the spatial relationship? How long is it? How deep is it? The amount of data that you need to answer that question is surprisingly small. And so what do we do? So if the basic data that you collect when you're a sketcher is, of course, you're putting everything on a survey line. So you're with the survey team. If you don't know how to, if you're not real familiar with the survey process, it would be to your great advantage as a sketcher, or to be a sketcher, to learn how to do that, because ultimately you're going to kind of run the survey. And so if you don't know what you're doing, then, you know, that's a little bit, you know, that would be to your advantage. But basically what we're doing these days, and notice I said using fiberglass tapes on here. I made this slideshow before I bought a Disto X. So your measured distance, it's going to be a little old school, but you can use a tape or a Disto X. Your bearing or your azimuth, that's just the direction. And you're either going to have a compass or a Disto X. Your inclination, you can do that with an inclinometer, or obviously your Disto X. And then for surface surveys, you really need to be working with a GPS location too, because if you don't know where your cave is with respect to the surface, well, you need to know where your cave is with respect to the surface. Just as a little aside about Disto X, I love them. I think they're great. But when you're an inexperienced sketcher, the thing that happens with the Disto X is people collect a lot of data before you even have a chance to record it. So you got to keep that in mind, and those of you who are on survey teams, keep that in mind too when you're giving data to your sketcher. So not only do we want to know where the cave goes, how long is it, what the deal is about it, we want to know what the dimensions of the cave are and what's the shape of the cave passages, because those are important. Even if you're not a science geek, even if you're not a geology geek, as a cave explorer, knowing a little bit about the geology of your cave is only going to help you find more. So what do we need to answer those questions? Here's an example of a survey page. And notice this is a pre-printed survey page. The sketcher on this wrote very neatly, so there's no question at all, there's no doubt about what any of those numbers are. Because keep in mind, unless you're going to do everything, unless you're going to enter all the data and make all the maps, which I don't encourage you to do all of that, what you make has to be usable to other people, which means your sketch needs to be legible and your survey notes need to be legible. And I know people are going to say, well, you know, what if I'm sketching in a really wet, muddy cave and my notes get all muddy? It's not my fault. And my answer to that is, you know, there's ways that you could keep your book clean, or you could wipe it off as you're surveying. Or, you know, you can always lick it off. That's a good way to get it nice and clean and inspire you to not get it dirty. So anyway, passage dimensions are important. Left, right, up, and down, if you don't know what I mean by passage dimensions, not only for making, you know, the hand-drawn map, but also for doing some really cool digital representations. If you come out of the cave with good data and passage dimensions, this map that you see right here, right now, you can generate that like is for as quick a time as it takes you to enter that data into a software program. So by taking good cross sections, by making note of, you know, what is the shape of the passage, you can learn a lot about the cave. Not only is that useful to you as a cave explorer and somebody who wants to find more cave, but it's also really useful for anybody who's studying the caves in the area. And so my goal when I'm taking notes is to have good enough notes, not only to make a map, but also to maybe act as some baseline, you know, scientific information for people who want to come behind me and study the cave. And that's always a good thing. When you make really good notes, by the way, it also makes you very popular and everybody wants you to go on their cave trip, because one thing that we're dearthly short of are sketchers. So not only are you sketching the shape of the cave and how long it is and how deep it is, but you also need to put the features inside the cave. And that's the part that's the tricky part. But it's not impossible. It's a skill. It's a skill that anybody and everybody can learn. You just have to take the patience to do it. And hopefully today we give you a little idea about how to go about doing that. So there's lots of stuff in the cave. Sometimes you don't even know what it is. You don't recognize the significance, but if you see something weird, write it down in your notes. You don't have to know the symbol for cave salamanders or square cubic cave pearls. Take notes. So your observations are what also need to go in a sketch. Don't hesitate to write down things that you observe. And so all of this stuff, you know, we gather all of this stuff and we put it on sketches. And this is kind of what our cave sketches look like. The sketch on the left, that's the plan view. That's kind of the bird's eye view. If you were floating above the cave passage, that's what you're looking down on. All those little numbers there with letters, those are our survey stations. It's absolutely critical that you have survey stations, because if you don't, well, your sketch is going to have very limited value. Notice in the cross sections that we also draw in the detail that matches the plan view, okay? And in the profile, we do the same thing. So even though you're drawing a cross section in a profile, you still want to include the floor detail in those. Now, if you're just learning to sketch, the easiest thing, and those of you who are already experienced sketchers, if you want to make more sketchers, then recruit some people on your team to start working on cross sections or to start doing the profile, because those are the easiest things. They're the easiest things to understand, and they're the easiest things to draw. And it starts to get people used to thinking about the cave in 3 dimensions. The most challenging view to draw is the plan view, because it's more abstract and it's got more symbology. So of course, we're not going to, get into data entry or software or anything in this, in this workshop. But ultimately, that's what happens to your data. It doesn't like go, in a box and gets filed away, I hope. It gets entered into a software program, it gets made into a line plot, and it gets made into a map. And so this is actually, that's really important. This is what your line plot looks like. Because when you survey a cave, no matter how careful you are impacting the cave. You are human impact, you're walking around in there. So you need to make all of your walking around and your team that's with you that's walking around, you need to make it like worthwhile, which is come out with some good data, come out with good sketches. And ultimately, your sketches will be used to make a cave map. And that's really the whole point of all this, is how to make a cave map, or to provide the data for someone, either you or the cartographer or the project cartographer or anybody, to make a cave map. Also, being that we're generating computer data as well, so there's other things that you could use it for. We can use it for GIS, that's Geographic Information Systems, which at one time was kind of a difficult, hard to obtain, hard to have access thing to use, and now it's much more accessible, and it gives you, a place, another level up to take your data and to use it well. And of course, this is all just, this is of interest to anybody who's wanting to study the hydrology of an area, or, the geology. Your cave data is important to them. They're going to do other things with it, but your data is important. So, that's why it's all important. And one really cool thing that you could do with your sketches, if you make good sketches, is you can actually turn them into you can take your sketches and make them into preliminary cave maps. This is a terrible screenshot of Caveware. And Caveware is a software that's authored by Philip Short. And basically you scan your sketches, you put them on a line plot, and it makes you a 3-dimensional sketch of the cave, or a 3-dimensional map of the cave, directly from your sketches. And so you could come out of the cave, sit down, the same day, enter all this data, and you have a working map to start working, to start continuing your exploration. And of course, you want to be a badass sketcher. That's what you're all here for, right? This is what a badass sketcher looks like. Even though they're in there in the crawlway, they're still there with their book and their protractor and their multiple pencils. And I wish I would have got a shot of that. But that's a Missouri caver, and I can guarantee you Missouri cave mappers make really good sketches. So what do you need? Sketching tools are surprisingly inexpensive. You need a protractor. You've got to have a protractor. And there's all sorts of protractors out there. What I'm showing is the Caver protractor. And I don't remember who sells these, but you can get them they're pretty common. And they're real handy for helping you make a good plot. That pencil, why would I put a pencil up there? That's my absolute favorite, most precious pencil anywhere for cave sketching. It's kind of expensive. You buy them in boxes of 20 or 30 and they're like 50 bucks. But they make wonderful sketches. They're really easy to use. I highly recommend it. Of course, you want Write in the Rain paper. And I noticed that there's paper out there that's not really Write in the Rain, but it kind of looks like it. So you need to be sure when you buy your cave paper that it says Write in the Rain. And the reason why that's a big deal is because the paper starts to absorb humidity. And it gets to the point, if it's not Write in the Rain paper, that you can't write on it anymore. And you definitely can't erase on it. And it's not like it takes a whole trip for you to figure that out. it starts happening like really soon. So be careful of the paper that you buy. You can buy pre-printed survey sheets. Those help you keep your notes organized and neat. Or you can have blank sheets, and you can get more data on blank sheets than you can on pre-printed sheets, but that has its, issues too. And then of course, I like having a survey notebook so that I could pull my survey notes out and we can scan them, store them, do whatever. I really like the little yellow survey notebooks. I also like to use a clipboard, which I'm not showing here. And if you're in really big passage, or if you're in cave passages that are really mazy and complicated, then sketching on an 8.5 by 11 sheet of Write in the Rain is totally the way to go. And they have clipboards that are folding, and they're really lightweight and easy to stick in the next thing I'm going to show you. And so, so clipboard sketching, that's something that you do maybe when you're a little bit more experienced. So back to protractors. Of course, there's the cave protractor, but what's really great are these orienteering protractors. These things are like, they're they're more stout than the cave protractor. The cave protractor, if you're not careful, you can bend and warp it. This is like plexi plastic or whatever. And the way you're going to use this is you're going to spin the dial around and basically dial in what your vertical or horizontal angles are. And then you have a ruler on the side to scale it out. So what you want is ideally is to have a protractor that has a ruler attached to it. You can come in with a separate scale, but you want to minimize the stuff that you have to deal with when you're sketching. And of course, you got to have a stylish cave survey bag. These are cave skins. I don't think they make these anymore, which makes me sad because mine is about to wear out. But there are plenty of cave survey bags available. They're great for if you're gonna, while you're caving, if you're gonna be climbing on something or doing something where you need to put your sketchbook down to travel, put all your stuff in your handy dandy survey bag, zip it up. You can go to the next station and everything in there is protected. It's well worthwhile to have it. I also use it to keep cave snacks, not necessarily for me, but sometimes to bribe my survey team so they don't mutiny because we're spending hours and hours surveying in a cave. I can probably outlast any survey team too much to their dismay. So before I go on any further, does anybody have any questions about anything that I've said so far, or comments or anything that you want to make? Chris, nothing on the chat?
Nope, not yet.
All right. So some of you guys are going to be bored to death with this. Some of you are not. But basically, I just want to show you quickly how to use a protractor. I find that I've done survey workshops for freaking 20 years. And at first I didn't understand why some people had such a hard time picking up sketching. And then I realized it's because they didn't know how to use a protractor. So rather than asking who does and who doesn't, I'm just going to show everybody. This is one of those cool little cave protractors that I'm not going to demonstrate how to use. That one you really need to know, you kind of need a face-to-face person for that. And I think that there's probably videos that will show you how to use this. But what you need to know is you need to have that survey protractor in your head, okay? And what that means is that, notice that it's a 360 protractor, even though I have 90 facing the wrong way. It's a 360-degree protractor, and as long as you know where 0, 90, 180, and 270 is, even if you lose your dang protractor, you could still come relatively close to making a reasonable scaled sketch. But having that in your head then allows you to use a half protractor. Some people freak out. They're like, where's the other half of the numbers? How am I going to know this? Well, put that protractor in your head, and you'll never have that problem. And so we always start, obviously, you're going to start your survey line somewhere on a page. And I know that people are going to ask where, and we can talk about that later. So what you do with your protractor, oh, here's one of those half and half protractors. These used to be really common. I still have a bunch of these. And the thing with the half and half protractor is, it's if you have the protractor in your head, like I explained, then you don't even care what those numbers are. All you care about is the increments, and then you can easily count them off without any problem. And with this, you just flip it over, and so you got your 0 to 180 and your 180 to 360 on there. I don't know if, how common these are anymore, just because of the cave protractors and the orienteering protractors, but, just so you know. And so every place, what you're gonna do is you're gonna start with a survey station. And you're gonna take the 0 point, you're gonna take that little point and you're gonna put it on the survey station. And then you're gonna read off of the protractor, you're gonna read what the azimuth is, and the azimuth is the bearing. And then you make a little dot wherever that is on the line, and then you take your ruler and you join it together. And so there is your first survey station. Really simple, really easy. You need to be able to do this like in your sleep practically. If you want to be a really efficient sketcher, there's no such thing as a fast sketcher, but there's an efficient sketcher. You can actually, if you moderate your survey team, you can actually keep up with the survey. And you do this by making certain things second nature, and plotting is one of those things. You do the same thing. You always start at the next station. Some people get confused and want to keep plotting from the first station, but you just go from station to station to station, measure it off your protractor, and you're good. And of course, you're recording the data as you go, and I'll talk more about that later. I'm just talking about protractor right now. Now, how do you plot the profile? And this has also caused people confusion, because they're like, well, I don't know what to do with all the numbers on the protractor. How do I know how to plot it? Well, your handy dandy little protractor, the one that had 360 degrees on it, now turns into a protractor that has 180 degrees, from 0 to 90 and from 0 to minus 90, just like you see on the sketch or on the slide there. And it's the same principle as when you're using the protractor, the standard protractor, but your 0 now is I mean, on what you see on the screen there, it says 90, right? But that's really 0. So you're thinking of that is your horizontal line. So you line up your horizontal line, you figure out where, and you're counting down from 90, which is really 0. In this case, I want to plot minus 30. So I'm going to go 0, 10, 20, 30. So even though you don't see 10, 20, and 30 on there, that is what you're counting down. Once you do this a few times, it will get really easy, and it will be second nature. You just get really good with that protractor. Same way, you just, so you're plotting either 0 to 90 or 0 to minus 90. That's what your numbers are going to be. And so that's kind of the basic how you use a protractor. You really need to have a protractor with you in order to really do a good job on your sketch. The more accurate that you can make your survey line, the more accurate you'll be able to locate things on it. And when you give it to your cartographer, it'll be easier for them to make the map. You don't want to make your survey notes like a mystery where people don't understand, like they have to take it, they have to get it interpreted. You want it so that it's neat, it's easy to read. It does not have to be a work of art. It just needs to be a work of neatness and clarity. People ask about survey symbols. It's like, oh my God, I don't know all these symbols. Well, there's a gazillion different symbols out there. There's a number of different symbol sets. You really only need to use a few basic ones, maybe 10 or 12 at the most. And so what I suggest people do is they just laminate a symbol set that they like and stick it in your survey book. You can reduce this and make it into a 5x7 sheet, and then you got it. And so you always have it there for reference, should you think that you forget. But what you want to get to the point where you don't need the symbol sheet anymore, that you've had enough, you'll know that you've had enough practice as a sketcher that you don't need to consult that anymore, because you've got it basically down to memory. And that will happen if you sketch enough. Sketching is all about practice. It's not like the black arts or a special skill. It's all about practice. You practice enough and you'll get good at it. So does anybody have any questions about any of this other stuff? No? No, Chris?
Nothing yet.
Man, I'm either like really good or everybody's confused or they're too shy or I don't know what the deal is. You're like my students. I have to like pull teeth to get them to talk to me. So what I'm going to do is I'm going to give you a little overview on sketching to scale. And keep in mind that when I teach this class, after every little lesson that we do, we go out and we practice. We get hands-on. And I don't exactly know yet how to do hands-on virtually. So anyway, that's how you learn, is you learn it by doing it. So here's an example of a plan view sketch. Let's look at a couple things on it. It's got survey stations. Do not forget to put your survey stations on the sketch. Even though you say, oh, well, I'll label them later. Don't label them later. Do it as you go. On this one, we see what, Z8 to Y22, if you look at the left side of that sketch. So when I'm making a sketch, the only thing that I look at is the station that I'm at and the station that I'm going to. I don't look behind me. I don't look at the big borehole or the nasty crawlway ahead of me. I go from station to station, and that is critically important because you only want to focus on that little chunk. And as you're sketching, you're like taking another little bite of the cave and you're sketching it as you go. You don't put the survey line in and go back and try to draw it in. Or you don't take the numbers down and go home and try to draw it. No, you might draw something, but it's not going to be real. So sketching is all about station to station. As soon as you get a station, you want to label it. You want to put your survey line in next, and I'll explain, the process of how you get from a survey line to the passage walls to the detail, and that's kind of what you're doing. And of course, as you go along, you're putting in cross sections. As a beginner sketcher, it's real easy to get like task overloaded on this, and so it'd be a good idea to practice making cross sections first on a real survey, not on a practice survey. I don't, people say, oh, I'll shadow sketch. Don't shadow sketch. Get in there and either do a profile and a cross section. It will help you start to think in 3 dimensions. As you notice, these cross sections, they have passage detail in them as well. Now, you might notice on some maps that people actually put the lithology, the rock type that the cave is in. And you can do that if you want. I like to put those on my cave maps. I don't necessarily put them on my sketches because they take a long time to draw. And so basically I want to get basic information, and I can always draw in what kind of rock it is later. The chances are pretty good that what you're surveying is limestone. This is not limestone, this is a lava tube, but on the final map, you would see that. You could make a note on this, lava tube cave, or you could say cave in limestone or whatever. Some people are, if you got some time, sketching time, and you want to put in some lithology, go ahead and do it. And to me, if you're going to draw in little blocks of limestone, you need to make a legend and indicate what that is. And you also need to indicate, are you just using it symbolically, or are you usually using it to represent the real geology? I recommend you go for symbolic until you get like really experienced at it, because some areas, some caves are actually quite complex structurally. And if you don't understand that, then that's going to like blow your mind for trying to make the sketch. And your goal here is to make a cave map. It's not to understand the whole geology of what you're doing. So, you got to understand that your sketch is supposed to be a representation of the cave. So it needs to look like the cave. So You need to put, if you have big features like big pieces of breakdown or real distinct features in the cave, those need to be on your map. Those need to be on your sketch. And remember that you are working for a cartographer, unless you're the cartographer. You're working for you too, because you want to be able to come back with a set of notes that is easy to interpret and use. The best case scenario is that this cartographer can take your notes, scan them, and just trace them. They'll put them on the line plot and they're close enough that they could just trace them. That's the ideal. That's like the gold standard. So if you do a good sketch, you're going to make cartography a lot easier for the cartographer. If you're careful in recording your numbers, and if you plot all of your data out properly, then you're going to minimize making errors in the cave, making survey errors. When you're in really complex mazy areas, you can actually see if your survey lines don't close when you've done a loop. And if you don't understand that, I'll explain that in a bit. You'll be able to tell that as you sketch to scale. You'll know in the cave, you know, if you did a good job of collecting the data and plotting it out. And the other things, as I said, it's all about getting the best product possible to your cartographer. So here's a couple of other examples, some cross sections and plan view again. And notice there's some really big rocks in this cave, and the big rocks that I draw are really there. The little rocks, I tend to make them more just representative, okay? I try to put features where they are in real life. And if you're, what I also like to do is I like to carry an extra compass with me. And nowadays, since nobody likes to use the compass anymore because everybody's got disto X's, I have a compass, and what I can do is I can take a compass bearing on any feature on my sketch to make sure that I put it in the right place. So just like you plotted the survey line, just like I plotted A1 to A2, as you can see, you see my letters in there. I took a survey shot to that big blobby looking thing where B is to see exactly where that is. I represent the breakdown as a little bit generic. If it's really big breakdown, I'll try to draw it in the correct orientation and in the correct place. But if it's a bunch of small rocks, then I just do that as a representative, okay? If you need to have a sketch that looks so precise and exact that every little rock needs to be in the right place, then maybe you need to be doing LiDAR or photogrammetry. You know, your goal is to make a good representation of the cave. You don't have to make it, you know, 100%. And then also notice that those cross sections, they all have detail in them. And there is a profile that goes along with this as well. So I do not draw the plan view and the profile on the same sheet of paper. I draw the plan view on one piece of paper, and then the very next paper under it, the very next sheet of paper that I flip over in the notebook, I turn the notebook to landscape view, and then I draw the profile on it. So they are on separate sheets of paper. Depending on how big the cross sections are, I may put those on separate sheets of paper too. Now keep in mind, notice on this sketch that I have two pieces. I couldn't put the entire thing on that one piece of paper, or at least the continuous sketch. So it's okay to do your sketch in segments. It's okay to have a couple segments on one piece of paper. If you've plotted them well and your data is accurate, your cartographer will have no problem trying to hook those all together into making a map. Has anybody got any questions on this or anything here?
Yeah, I got a couple. One from Jeff is, what's the appropriate reasoning for identifying a station? Like, why do we need to show the survey stations on the map or in the sketch?
Okay, so why or how? Okay, what you can use is you can use a very heavy dot as a survey station. You can use a triangle, you just got to make sure that your triangle doesn't get mixed up with your stalagmites or your stalactites. Those are the general thing. You want to make a little square. Whatever you put in there, you want to make sure that that station is identifiable on the sketch. And you want to have a line, a very faint line that connects your survey stations. And what you do as you're surveying is you walk that line. So when I'm in the cave making this sketch, I started at A1. And the first thing I did was I plotted A1 to A2. I made the plot first. I also got passage dimensions at A1 and A2. And I plotted those on my sketch too. And then what I did was I started at A1, and being that this passage is, let's see, where's my scale? It's not humongously large passage. It's nice size, but not humongously large. You can eyeball pretty easily up to 30 feet. Beyond that, it's hard to do that. And so, you know, what you could do is as you walk the survey line, you can get your survey team to take some shots to the walls if you want. And basically, if you record those, if you plot those on your sketch, you don't necessarily have to write them down. What you have to write down are the survey stations, the distance, the bearing, the inclination, and the passage dimensions. And then as I walk that line, I might walk, I'm going to walk about 10 feet. And I'm looking to my left and I'm looking to my right and I'm eyeballing where the wall is. And I start drawing those on the paper. Now, as I'm walking the line, the reason I walk the line is so that it gives me a good guide on where to put the walls. You also want to don't forget to look up, don't forget to look at the ceiling, and don't forget to look at the floor. And so what you do is you're moving slowly as a sketcher. So you don't just sit down in one place and sketch from A1 to A2. What you do is you walk it. You have to walk it, because otherwise it's extremely difficult to put all the features in. And as you go, you label all those stations. Does that answer the question? I probably told you way more than you wanted to know.
Yeah, I think it was way more. He was also just looking for, and it got answered in the chat, was just where do you set a station when you're out there? You know, somewhere that you can easily get, you know, make shots from, somewhere, you know, somewhere that you can continue the survey.
Well, you have to set your stations where you can see them from, you know, you got to be able to see the stations. Is that what you mean? Like,
yeah.
is the question, like, where do I put a station? So if I'm at A1, A2 needs to be someplace that I could see from A1. And it also needs to be someplace that can be seen from A3, because it's all line of sight survey. You have to be able to see the stations.
And then the only other one was maybe, could you explain or remind us some of the symbols? You got 4 symbols and ceiling symbols on that plan there.
Okay, so the general rule is if you have dashed symbols, like if you notice on the left wall, I have these little dashed, you know, symbols with a little hatcher facing the wall. Okay, and that means that's basically a ceiling height change. But the important thing about it is that it's dashed, and a dashed symbol means it's on the ceiling. If you look up where it says Rimstone Dams, just a little bit below Rimstone Dams, you see a straight line, a not dashed line with little hatchers on it, and that's a ledge. So that's on the floor, and that's how you differentiate between your ceiling features and your floor features. So if it's dashed, it's on the ceiling. If it's a straight line, it's on the floor. Does that help?
Yeah, and that actually answered the third question as well.
Okay. No other questions? I can't see the chat, by the way. That's why I'm like depending on.
Yeah, you're good. That was one of the other questions, was how do you distinguish between floor and ceiling features?
Yeah, that's how you do. Now, I do want to make a point that when you have, say you're in the cave and you're looking up and you can see that there's an entrance up there. So maybe the way that you got into that cave was from a pit. And so there's a little bit of controversy on how do you show that on the sketch? Do you show it with dashed lines, or do you show it with solid lines? And, you know, to me, when you're making the plan view, you're on the floor. And so if you look up and you see a hole in the ceiling that you came into the cave in, that's still a ceiling feature. Now, if you were on the surface, okay, and you were looking down into a hole, then your line would be a solid line, and that would be a floor feature. I know that's a little bit confusing. The bottom line with any symbol that you use, though, is ultimately, if you do something non-standard, then put it in a legend. Make a little legend symbol. You can make the symbols mean whatever you want. I mean, it's nice to have some standards, but if you decide to use something non-standard, that's fine, but make sure you indicate what it means so that your cartographer knows. And if you're the cartographer, make sure that you make something so that the people who use your map know what it means as well. Okay, here's an example of the profile. And the profile, we typically think, oh, well, we only need to put a profile in a vertical cave. And of course, here's an example of a profile in a vertical cave. Notice I also label all the survey stations. Notice I have a little square with the 6 in it. That little square means that that was a climb down. And typically, what I also do, I didn't show it on this sketch, is I like to show the rigging. I like to show what it took to get down to wherever you were in the cave, because I think the rigging is really important. I like to put that on my maps. Some people don't like the rigging included on the maps because they think it's too much information, and that means that people will now know what they need to do the cave, and lots of people will do the cave. Well, maybe that's true. But then, so your rescuers know what they need to. So anyway, use the rigging when you can. Notice also that on one of the right walls where it says Z24, I have these little marks coming off the wall. And those, that means that that was flowstone on that wall. That's what that symbol means. Now, just because you don't have a vertical cave does not mean that you shouldn't do a profile. I think you should always do a profile, because there's things that are on the ceiling that you can't really show well in the plan view, okay? So make a profile no matter what. If it's too much for you to do all 3 views, then split up your sketch. I have done plenty of surveys with 3 sketchers, where I had somebody doing cross sections and I had somebody doing a plan or a profile view. I can do all 3 views too, but you know, I also find that's a good way to teach people if you do that. So if you're gonna make a really good scaled sketch, you know, obviously you need the plan view, you've gotta have cross sections. A running vertical profile is fine. Some people who know my maps notice that I make sort of 3-dimensional looking maps, or I try to. I like to give them a 3D look to them. I do not draw them like that in the cave, okay? I'm not sitting there drawing a 3-dimensional profile. I draw a standard running profile, and then what I do is, that's sort of my interpretation. I have to go through some mental hijinks to get it to look like a 3-dimensional, and there's some artistic license too, but those things are not done in the cave. So, you know, you always need to do all 3 views. It's critical. And same sketch, just showing. Notice when I make the cross sections that they are tied to something in the cave. You don't just have random floating cross sections, because then how do you know where those, what they represent in the cave? So you can do those little lines that you see, the red arrow is starting, those are leader lines. And you can do them a couple different ways. In this instance, I put leader lines and then I put letters. And then I put the same letters on the sketch or on the cross section, so you know exactly what you're looking at. If I didn't have those letters on it, then what I would do is I would put a little tick on the shorter of the leader lines, and it would face the direction that I'm going. So, you know, your tick marks point in the direction that you're looking when you're sketching. But if you don't like the tick marks, you can use the letters, and those are just as good. One thing I don't think I mentioned, every sketch needs to have a north arrow on it. You know, don't assume that north is always going to be up. Sometimes your cave is doing crazy things and it's using up all your paper and you need to be facing it another direction than up. So always put your north arrow on. You can change the direction of your sketch if you want, but then you got to change your north arrow as well. And always put a scale on there. Every sketch page should have a north arrow and a scale on your plan view for sure. You know, and don't think that, well, I'll put it on there later. Like, do it now. Do it when you're sketching now, because you'll have plenty of other things to put on your sketch later. And then, of course, just some other fuzzy examples of profile views. The one that says A234, that actually has a little story to it. And that's a little section of Lechuguilla Cave. And the reason why I included it on there is because when we first started surveying in that cave, we had line plots. Like basically, you know, everything was a line plot. We didn't have maps yet. And some of the people in Carlsbad saw our line plots, and they saw them in plan and they saw them in profile, and they decided, well, you know what, this cave is flat. So why can't we drill another hole into this cave and develop it so that we can bring more tourists to Carlsbad, to the Carlsbad area? And it wasn't until we showed them what the cave really looked like, they didn't realize that there was no flat passage in the cave at all, and that we were just standing on top of breakdown mountains and big sediment mounds in order to see the survey stations. So anyway, that's why profiles are good, but you got to have a good sketch to go with it. Does anybody have any questions about those? Because I'm going to kind of walk you through how you actually make a sketch in a little more detail. None?
Doesn't look like it.
Okay. So the first thing you do, obviously, is, well, you're writing down the numbers. And keep in mind that you need to repeat your numbers back to your survey team. Okay, if you write down the wrong numbers, if you didn't hear them correctly, that's going to cause you a lot of pain and heartache in addition to you and your cartographer. So whenever I'm sketching with somebody, and they'll tell me, I want the survey team to tell me everything. I want them to say, station A1 to A2, distance is whatever it is, bearing is whatever it is, inclination, front sight, back sight, left, right, up, down. I want them to identify those numbers so there's no doubt in my head what numbers they give. That way I don't have to think about the numbers. Not only do I want them to read them all out to me, I'm being mean here, but I do it anyway. I do this, is I want them in a specific order all the time. And the reason for that is so that I can focus on making the sketch. So I don't have to think about what number was that they gave me? Was that the left or the right? They give it to me in the same order all the time, and they always identify the numbers. That minimizes survey errors. It's so easy to misrecord a number. It's very easy. And so that's why, that's kind of a way to it's quality control is basically what it is. And so even though I show here that I've sketched like 3 stations, in real life, what I would have done was I would have done A1 to A2 first, okay? And then what I would have done is I would have walked that survey line, and I would have been looking to the left and to the right, and I would have been drawing as best I could where the walls were. And this is a little bit of artistic license here. If you're not exactly sure, if you're like, I'm not sure where that wall is, measure it. Especially if you got a Disto X or a rangefinder. There's no reason in the world why you can't take a measurement on that wall. It's real easy to do it now. And if you do it with the Disto X and find out exactly where the wall is, it doesn't take any more effort, and it makes for more accurate representation of the shape of the cave. So what I would have done here is I would have gone from A1 to A2, and I would have drawn the walls. I wouldn't have drawn all this other stuff in there yet. And then I would have put in a cross section. I like to put cross sections in at every station, but sometimes the passage is the same for like, you know, a long way. So rather than only putting one cross section in, maybe I might put them in every 3 or 4 stations, or maybe every 5. But every time the passage changes character, you need to put in a cross section. And if your cross section is not at the station, it's okay. You just need to make sure that you indicate on the sketch where it is. And so then from A1 to A2, I see a ledge on my left wall, and that's what that solid line is. The ledge is on the floor. There was a stream in there, so that's what the little arrow is, and I was showing the direction of stream flow. I had a whole bunch of really fine-grained sediment on the floor, and I just call it fine-grained sediment. It could be mud, or it could be silt. If it's a bunch of sand, I might make a note of what the fine-grained sediment is. Okay. As I went at A2, notice I have some dashed lines. That's stuff that there's a ceiling change there, so I drew those in. The high part of the ceiling is, well, the low part of the ceiling is the direction that the little ticks face. Then you notice again on the left wall, there's another solid line with the ticks facing inward. There's a little hole in the floor there. And that 10 with the circle around it, actually, that means that there's a 10-foot ceiling height. So when there's a circle around a number, that's the ceiling height. And it probably was not a significant drop, so I didn't put a little square with a number in it. But if that had been like over maybe 4 feet deep, then I would have put a square and I would have indicated how deep that thing is. And then as we continue on, you can see I have these 3 little splays that I hope don't look like chicken feet, because I hate chicken feet, but that's kind of what they look like. And it's a slope. So as I was going, as I went from A1 to A2, I drew all that in first. And then I went from A2 to A3 and I drew all that in. And I went from A3 to A4 and I drew that all in. I did it as I went. Put the cross sections in as I went. I did the profile as I went. That's like really, really important. Also as important is there is always something on the floor. Okay, there's no such thing as an empty floor. You know, if it's bedrock, there's a bedrock symbol. If it's water, well, you know, there's water symbols. If it's sand, if it's silt, if it's something, you need to always indicate what's on the floor because it's important. And any kind of obstacles, you need to show those too. And the obstacle could be like, you know, there's a big hole in the floor. There's a big breakdown pile that goes to the ceiling. There's any number of things. Those are all, you know, what detail do I put on my sketch and how do you know what's important? And what I do on my field part of this course is we'll go in there and we'll do a timed survey. And what that means is I give the sketcher like 7 minutes at the survey station, and they need to draw on the sketch everything that they think is the most important thing. And that's sort of a little bit torturous to them initially, but it makes you think about what's important, because you can't include everything on the sketch. A sketch is just a model of the cave. It's not the reality. If you have to know every single thing, then like take pictures. If something is really important, then take pictures as you go as well. You know, make a lot of notation on your sketch. It's okay to make notation on your sketch. Any questions so far? None.
Doesn't appear like it.
And of course, I showed you earlier how it was that you map, how you plot the profile, okay? And so many times your profile is gonna look kind of flat, but that's not what the cave looks like, and that's why you need a profile. So if you look at the sketch that I have here, and once again, the profile is also done the same as a plan. It's done from station to station. I did not leave A1 to A2 until I drew everything that needed to be drawn in there. Then I went from A2 to A3. And I've seen people try to like, you know, not do that and say, well, I'll go back and pick it up. You know, walk the line. That's, you know, be Johnny Cash and walk the line when you're surveying. Notice I also have a little bit of detail outside of the cave, and people tend to like leave that out. And I think that the detail outside of the cave is actually kind of important. What's the entrance look like a little ways? It doesn't cost you anything to take an extra shot or two to give an indication of what's outside of the cave. because the cave is not totally separate from the surface. The cave is, you know, part of the whole landscape. So kind of draw it in the landscape. You know, those trees are very generic. Like, once again, you can take a little bit of artistic license when you're drawing things. It's okay. So here, I just have a couple of these to kind of give you an idea of, you know, how would I sketch this? Like, what would I do? So I started, I'm going to put me at the left-hand side of the sketch. And typically I like to survey with experienced cave mappers, because then I don't have to tell them where to put the survey line. Okay. The critical thing about being efficient as a sketcher is you have to focus on the sketch. You can't have a conversation, you know, you can't be talking to everybody and sketch at the same time. You got to keep your mind on it. And if you do that, you'll be able to keep up with the survey. You'll be very productive. You'll get a lot done. If you don't, you'll get confused. You'll misplot things. You'll forget where you did things. So anyway, but if my survey team asks me, of course, I will tell them. And so basically at the far end, and I should have put station labels on this and I didn't, but let's just say I'm starting at C1 and I'm going from C1 to C2. So that's at the far left side. And you can see that little place where the two lines join together, and that's a survey station. It's all line of sight. You know, you have to be able to see the line from station to station. And then what I do is I start walking that line. And how do I draw that? Well, I have a big column right there, you know, to the left of me. So I'm drawing in my column symbol. I'll either have my survey team or I'll do it. I'll take a shot to the wall so I know how far the wall is. And I'm doing that at C1. I'm not really moving yet. I want to get as much as I can at that first station. And then I start walking that survey line. And as I walk it, I look and see, oh, the floor has got a bunch of flowstone on it. So I'll draw some flowstone. I'll look up at the ceiling and I see that there's a bunch of stalactites. And so I will draw stalactites. Now you're wondering, oh, well, some of them have draperies on them, you know, or there's more detail. Keep in mind that you don't have to draw in every single like soda straw that you see. Unless there's only 4 of them, then maybe you'll draw 4 of them. But if you have, you know, massive amounts of speleothems, what you want is to get the major ones. If they're big, you need to put those on your sketch. If there was a whole bunch of little ones, as you see, like more toward the middle of the sketch, and we start getting a lot smaller ones, as long as I have the major ones in there, then everything else can be shown kind of generically, and that's what I do. I show them correctly where they are in the passage, but you know, I try not to be overwhelmed by the detail that I see in the sketch. And so I go from station to station to station to station. And that's really the best way to do it. Now, this little image that I used here, that's LiDAR. And you know, folks, one of these days, they're not going to need us anymore as sketchers. So, but right now they do. And so anyway. And here's another example of, well, where might I put some survey stations? This is also another LiDAR survey. If you look real close, you'll actually see some of the little LiDAR targets that are in there. So, you know, this would be a great thing for a beginner to work on, because there's not a lot of detail that they have to worry about. But there is some, you know, there's a symbol for the entrance. So you want to make sure you put that in there. Looks like there's a little wall at the entrance, and so I would put that in. Maybe, I can't tell if it's a man-made wall or if it's a ledge, but it would be a floor symbol. And then see where the slope is? I would draw a slope line, and I would draw a whole bunch of little dots for floor detail. And there's just, you know, as you look through this thing, you start with enough practice, this stuff gets to be like, you don't even think about it anymore. Your hand just automatically draws it. Honest to God, I know you think that that's not true, but it really is. And so, let's see, what else can I say? You can get a couple of really good cross sections in here. And I would draw a profile, even though it looks like, well, there's a little bit of vertical, but it looks for all practical purposes flat. I would draw a profile anyway, because profile is valuable. Some other things, there's some writing on the wall. I would probably make notation. Is that graffiti, or is that historical signatures? Or maybe are there some pictographs on the wall that maybe, you know, if I look closer, I might see one. Those are all things that, you know, as you get more practiced at it, you start to look at the cave really, really closely. And you notice a lot of things when you're the sketcher. You notice a heck of a lot of things, rather than if you're just running through the cave. What else do I want to say about this? I think this might be my last slide. Let me see. Oh, nope, here's one more. Oh, I think I have something after this about cave survey standards. But anyway, this is a piece of, this is a, let's see, cenote. This is an underwater cave. And, you know, to do underwater sketching is like, that's pretty amazing. Talk about being task overloaded. And probably every place that they show things is not 100% where it is, but it's representative, and that's what's important. Notice they have some really nice representative cross sections. And notice they have some stacked cross sections too, which means that that's something that you might not have been able to draw in the cave, because you might not have known that there was a passage below you. But if you have the sketches, then as the cartographer draws this in, they're going to know the elevation of everything. They're going to know how to draw that in. Notice there's also limestone on there. They drew little limestone symbols. Maybe, I'm willing to bet that the underwater sketcher didn't draw those in underwater. Maybe they did, likely they didn't. But they did note that it's limestone, and so you could put it in after the fact. And one thing I like about these particular limestone symbols is that they're very irregular looking, and I think that it gives it a real organic look to the cave, and that's kind of cool. You don't want your cave to look like a computer drew it. At least I don't like my caves to look like a computer drew it. So survey standards, I have to say something about survey standards. If you're surveying with a project, then you know your project probably has some standards. Standards meaning, and the reason why standards are important is because they establish consistency. If you have a whole bunch of different survey teams, you want everybody to be doing stuff the same way instead of everybody doing it their own way in some crazy way. It also helps with quality control. Quality control is a really big issue. Trying to survey, you know, accurately in a cave is not an easy thing to do. It's hard. It's easy to make mistakes. And then of course, what a survey standard does is it establishes what your acceptable level of instrument precision is. Like, am I measuring my compass bearings to the nearest degree or half degree or quarter degree? There's no, you have to do it X, Y, and Z. It's like, what's the standard of the project that you're in? And you try to stick with that standard. If you're running your own project, then you can make the standard any way you want. What you want is to make sure that your survey teams calibrate their instruments, because all the instruments are off just a little bit. And so if you have a compass calibration course, they're pretty easy to make. And you got to calibrate your distro X's too. They will fall out of calibration, and you might not even realize that they're falling out of calibration. So, you know, you want to calibrate them regularly. And this helps to maintain the accuracy of your survey. You need to be able to check the survey station, check your bearings, your back sights with your front sights. As a sketcher, you're kind of expected to pay attention to that. So if somebody gives you a front sight and then they give you a back sight, then you need to know, like, are they within, you know, within the 2 degrees that my survey standard is? And you may think, how am I going to do math? Well, I'm trying to make this sketch. It's really, really simple. If somebody gives you a number that's, say your station is, the front sight is 20, right? Or let me just say that the back sight is 180. So what's my front sight from there? Okay, so what you figure out, the way you figure out the opposite station is, if the number is between 0 and 180, then you add, let me get it, between 0 and 180, you subtract 20 degrees and now I'm getting myself confused. I know the answer to this. There's a really quick and easy way to do it, and I can't believe I didn't write this down. there's a quick and easy way. It's a matter of adding 200 degrees and subtracting 20. So if it's between 180 and 360, I think you subtract 20 degrees or subtract 200 degrees and add. There's some experienced sketchers on here. You guys help me out here. I know which way it is, and I'm just like slightly stressed and getting it backwards. So if anybody knows, type it in the chat so I'm not giving people the wrong information. Let's see, what else? Sometimes you'll have a cover page. It's always good to have a cover page. Even if you don't have a really nice cover page like this, get a blank piece of paper and put down what cave it is, where you are in the cave, put the date, put your survey stations, list your survey team. How much did you survey that day? How many stations? What scale did you use? All that stuff is good metadata. If you have a little cave that's the only survey that you ever did, well then you got all this nice information to put on your map. If it's a survey project that's been going on for 60 years, and there are some of those out there, this data is critical because it's historical data about the cave. It tells a lot about how the survey was done. If there was a problem, you could say, well, who are the surveyors? Who do I need to go yell at? Or I need to go talk to somebody and ask, like the sketcher, what the heck were you doing here? So this is metadata. It's data about data, but it's important. Knowing when you did the survey is critical because magnetic declination changes over time. So that's really important. After your survey trip, number your pages and don't just number them. Here's page 1, here's page 2, here's page 3. Count all the pages that have data on them or sketches on them and say you have 14 of them. So this is page 1 of 14. The next page is going to be 2 of 14, et cetera, et cetera, et cetera. So you know that you didn't miss, that you're not missing any pages. When you start dealing with a lot of data, it's easy to, misplace things. And you want to make sure that you know that you keep all your survey pages together. You want to write neatly and legibly. Notice in this page, I do not have a pre-printed survey sheet, but I made a big effort. I labeled everything at the top so you know what's what. I tried to keep everything nice and neat so it was easy to read. And so these notes are very easy to read. I also put my name on there as the sketcher so that if anyone has any questions, they can come back and ask me about it. And I put the day that I sketched. And also notice I've got, that's page 6 of 14. So this is important to keep, to keep your notes organized. As I said early on, you need to have a north arrow and a sketch on every single page. And your north arrow is going to be magnetic north. That's just the way it is. That's how the compasses work. You're doing magnetic north. And then later the cartographer figures out, what is true north. You don't have to worry about that. Make sure that you label all the stations. Try to draw a faint line between stations. That helps your cartographer a lot. If they can see, how that shows how things were surveyed, and it's really, really helpful. Some people notice there's a grid on this, and you can use the grid. Notice, of course, I made it 0 to 25 feet. If I had made it 0 to 20 feet, then you could have said that each one of those was 2 feet. So you can use the grid to help you determine, your distances. I put a lot of detail. Like I said, there's a detail on the cross sections as there are on the sketch, and there is a profile with this. It's just on a different sheet of paper. Oh, there's a profile. And so this was a relatively horizontal cave until I got to, notice where it says K20, and then I've got leads going all over the place. And what I did was I shot a bearing to each of those leads and I measured the distance. In this case, I triangulated because in 1998, I did not have a Disto-X or a laser rangefinder. But you can triangulate that stuff. I'm not going to go over that because you don't really need to know how to do that because you have other resources to figure it out. But there's a profile that tells you a lot about what you saw in that horizontal cave. And if you can't bring yourself to draw a profile in a horizontal cave, at least you can do partial profiles in areas that get complexity to it. Do it. It's important. It kind of really helps show the cave. And also keep in mind that just because you're surveying does not mean that your impact doesn't count. So you want to make sure, where you set your survey stations, make sure that you're setting them in a place that's not damaging the cave. And that, just because you're doing, well, I'm doing a survey, it's really important. So I could put it right here on these stalagmites. Try not to do that. Try to put them in places that have the least amount of impact. You don't have to walk all over everything, especially now that we have instruments that will measure a distance without you having to walk there. You don't need to put your footprints all over the cave. So you should make an effort to minimize, your impact as you're surveying the cave. And of course, we're expendable because someday, have you ever seen the movie? What was it called? I forgot the name of the movie. Anyway, where the geologists go into this big mine and they have these two orbs, and the guy throws the orbs in the air and they start running through the mine, and they're mapping the mine as it goes. And this guy is just standing there waiting for his orbs to map the cave. And then the guy on the mothership is watching the data come in, and it's making this beautiful 3D model of the cave. That's my dream. So anyway, I believe that is the end of, I think that's the end of my presentation. And so does anybody have any questions about anything? Prometheus? Yes, thank you, Michael. That's what